Hi everyone, how are you guys? Can you guys hear me? Okay, welcome guys. My name is Dave, if, for those who don't know me. We're just gonna go through the session because I'm not sure if the others will join shortly, but we can proceed with the session. I think they'll catch up. So the topic for today is your D operators. So the operators, guys, it's just your second order differentiation. So I'll just take you through that. Whatever that we're gonna cover, it's also based on your assignment questions. So I'll just take you through the basics. That's what I'm gonna do today. So I don't know if there's anyone before we can start. I don't know if there's anyone who has a question before we can start. Maybe the question that you struggled with, where I can guide you. If you do have a question, please let me know. Is there anyone who's got a question? Maybe the question that you struggled with during your assignment, or the one that you would suggest that I start with? Anyone? Anyone? Okay. Okay. Cool. So I'll just start with the basics of your D operators. So they normally call it undetermined method of coefficient. So let's say you have d squared plus 4d plus 4, and then y equals to. So this side, I'll just make it simple. I'll just equate it to a constant of 4. So guys, please let me know if my network is not sharp. Please let me know. Then I'll obviously try to use the other network. Okay, and then if I'm too fast, it's okay. Let me try to do this. Can you hear me now? Is it clear? Loud enough? Okay, perfect. Now I was far from the mic. Sharp. Uh, so if you have d squared plus 4d plus 4, and then they ask you to find, they say find general solution. General solution. So the first thing that you need to do is to find your y complementary. It's your y complementary and your y particular integral. So I'm gonna show you how to do both of them. Okay, let me just inform the other guys that we have a session. Okay, so here you need to find the YCF and your YPI, complementary function and particular integral. So what this means is that your Y general solution is equals to YCF plus YPI. So the first thing that we find, step number one, we find the YCF. So to find YCF, you're gonna take d squared plus 4d plus 4, and then you equate it to 0. So that's the first step. D squared plus 4d plus 4. Then you equate it to 0, and then you find factors. So you have to find factors. So the factors of this, it will be 2, 2, and then both they're going to be a plus. And then you equate it to 0. And then now you will say d1 is equals to minus 2. And then also d2 is equals to minus 2. So this means that d1 is equals to d2, which is equals to minus 2. Okay, so there's a rule, guys. There's a rule that you need to use. Since the factors are the same, I'm going to write here, same factors. same factors. The formula that you're gonna use for your YCF is as follows. These formulas are standard, guys, and then you're not gonna get these formulas in your formula sheet. You have to memorize them. So I'm gonna take you through the similar factors, complex roots, and also different factors. Okay, and then this one, YCF will be equals to C1E, and then D1 plus C2E D2. And then since, okay, we have to write X here, excuse me. And then since the factors are the same, you have to multiply by X. You multiply C2 by X because the factors are the same. You only do this if the factors are the same. This is the only time you multiply by X. Okay, and then now our final answer will be C1E, D1 is minus 2x plus C2E minus 2x all multiplied by x. That's how you do your complementary function. So far, do you guys have any question? So, okay. Okay, perfect. Let's move to our YPI. Let me just admit, I was supposed to make it auto admit. Okay, so the next thing that we're gonna do, we're gonna move to our step 2. So step 2, we have to find YPI, particular integral. So to get the particular, please mute your mic. Please mute your mic. You'll just unmute your mic if you have a question, please. Thank you. So now we're gonna find the particular integral. So guys, particular integral simply means that you're just gonna take, you see the y that you see from the original equation. I normally write it as pi like this. I just put pi like that. I normally put pi in front of that. So what you're gonna do here, you're gonna say it's pi, meaning I go to the original equation, I make ypi the subject of the formula. So meaning I'm gonna have 4 divided by d squared plus 4d plus 4. So that's what I'm gonna have. I have to put this on auto admit, but I'll fix that. So you're just gonna divide by your left hand side. So from the original equation, I just went there to the original equation, then I divided by this. I divided by that on both sides to make the ypi the subject of the formula. So that's what I did. Okay, that's when I solve for ypi. And then from here, I will use the theorems. So guys, to find ypi, you use theorems. If you go to your study guide, you will see that there's theorems that they use. There's theorem for 1.1, 1.2, 1.3. You don't need to know all those theorems. What does 1.1 do? No. You just need to know application. That's all that matters. Whether it's theorem 1.1 or 1.2, it doesn't matter. There's different theorems there. You need to master those theorems. So the theorem for the constant, the theorem that you use for the constant, guys, you need to know that a constant, it must have e to the power ax. That's for constant. So we can put e to the power 0x. So the theorem for e, what the theorem for e means is that even if you put x to the power 0, it's the same thing. So even if you don't put e to the power ax, you can put x to the power 0. But the only problem is that for x to the power 0, you don't have a. You don't have a. Hence, that's why I'm using e to the power of ax. Because if we say a e to the power ax, then we know that the d will be equals to a, which is equals to 0. So the value of a, it's always equals to d. Hence, that's why I'm using this theorem for e to the power ax. That's your theorem 1.1, the first theorem in your study guide. I'll present your study guide. So if you go to your study guide, you'll see the theorems that says e to the power ax, where d is equals to a. That's the theorem that you're going to use, okay? So we're going to come here and say ypi is equals to 4e to the power of 0x over d squared. D squared is equals to, so we said d is equals to a, which is equals to 0. So where there's d, you're going to put 0. You're going to have 0 squared plus 4 into 0 plus 4, which is equals to 4 times 1, obviously, and then divided by 4. So it's 4 over 4, which is equals to 1. And that will be your YPI. Then the final answer, which is step number 3. The step number 3, you'll have the general solution, which is equals to YCF plus YPI. Y complementary versus your particular integral. Then we will just add the two. We're going to take this answer and this answer right here. We combine them. We'll have C1e minus 2x plus C2e minus 2x times x plus 1. And that's how you're gonna do this one. So far, any question? So far so good? Or is there any question? Please let me know if there's any question. Yes. Or the d is close to 0 there. Okay. Oh, it's because remember e to the power 0x, if you put any number to the power 0, it's like it doesn't affect this value. Like if we say e to the power 0, it simply means that it's like 1. E to the power 0 is equals to 1. Yes. And then we know that using the theorem of E, A is equals to D, which is equals to 0. So I'm gonna show you the theorem now so that can make sense. Let me show you the theorem in the book so that you can understand it better. I'm gonna show you the theorem in the book. I'm gonna present the study guide just now. So it's met. Let me go to. Let me just present your study guide. You will see there. I'm gonna stop presenting because now I was presenting the. So now I was presenting only the window. So let me present the whole screen so that it can show you the what do you call it, the study guide, and also what I'm doing currently, where I'm writing. Okay, I'm gonna stop presenting. Okay, and now I'm gonna present the whole screen. Share the whole screen. Okay, there we go. And then I'll also share this window. So I'm gonna make it a split screen. Hopefully you'll all see. Okay, so let's go to your study guide now. So we're gonna go to the operators quickly. It's on page, it's module 3, page 57. Okay, let me just go page 57. 57. Okay, so this is your, it's 37. Let me just go to 57, 57. Still down there under the operators. So that's why you use your theorems. Okay, so I'm gonna present the whole screen for the study guide. Okay, so this is the theorem that I'm using, guys. Theorem 1.1. So theorem 1.1, as you can see, you don't need to master what theorem is this. So it says e to the power ax. I know it confuses a lot of people. It says e to the power ax, where f of d is any function of d, and a is a constant. So that a there is equals to d, basically, in a simple term. A is equals to d, to make it simple for you. A is equals to D. So you see there, I just summarized this statement there. Let me just zoom it in so that everyone can see. You see that statement, it says, note that the result is the original expression with D replaced by A. Do you see that? So that's the statement that I was talking about. For example, look at this example. Okay, I'll just admit, please wait. I'll just take this example. I want to show you something. So this example there, I'll copy it and then split screen, then to here. So that, okay, let me admit, there's someone who's trying to join. Let me admit, sorry about that. So I'm just gonna paste it here. There we go. So if you look at this example in the book, you will see that it says, for example, I'm just gonna explain to the lady that asked the question. So the question says, you have e to the power minus 3x divided by d squared plus 4. So this is the question that they gave you. Obviously, you cannot divide e to the power minus 3x divided by d. The moment you see the d, it means you must use the theorem. And if you see d as your denominator, you must use the theorem. Denominator, you must use the theorem. So that what determines what theorem to use is your numerator. The numerator will tell you what theorem should you use. The numerator will tell you what theorem should you use. So this one, you will use the theorem for e to the power ax. So it tells you already that you must use the theorem that says e to the power ax is equals to e to the power minus 3x. So here you can see that a is represented by minus 3. And then they said from the theorem, they did explain and say this a should be equals to d. It must be equals to d. So where there's d, you're gonna go and substitute minus 3. So we'll say e minus 3x divided by open bracket. So you're gonna open the bracket there. You're gonna open the bracket there and say minus 3 squared plus 4 is equals to minus 3x divided by 9 plus 4. 9 plus 4 is 13. That's how they got that 13. Does it make sense now? Yeah, sure, you're welcome. Any other question, guys? Any other question? You can ask, guys, ask any question, like even if it's assignment related, you need a guide on the assignment, it's fine. You can ask any question. I'm just taking you through the basics so that you can have a full understanding. When you go to the assignment, it's much easier. So, question one, is everyone done with question one? Everyone? Are you guys done with question one? Are you guys done with question one? Hey guys, done. Question one done? Because I wanted to guide you on question one. Everyone done? Yes, no? Yes, no? Can you guys hear me? Okay, so on question one, guys, which question is it difficult for you? 1.1, 1.2, 1.3, which one? Just tell me, it can be anyone. Like, obviously, just tell me which question you're struggling with, then I'll take you through that question. Which question? Anyone? Which question exactly do you want? The first one. Okay, that's fine. I'll do that for you. Guys, I'm here to guide you so that you can have an understanding. So this one is d squared minus 2d plus 5. We're gonna do this question together so that everyone can be in the same page. Plus 5. So if you look at this question, they want you to find the they said find the general solution. So guys, when they say find the general solution, you just have to say YGS is equals to YCF plus YPI. So here's this tells you that you need to find the complementary function, and then after you're gonna find the particular integral. Okay, so what we're gonna do now is we're gonna say to find the complementary function, that's number one, we have to find YCF. I'm gonna take d squared minus 2d plus 5, then I equate it to 0. Then I'm gonna find my factors. I'm gonna find factors. So what are the factors? Is it possible for you to find factors of this equation? Is it possible to find the factors there? Will you be able to find factors like using the bracket method? So it means you must use you must use this guy. So you must say d is equals to, yes, you must use quadratic. So whenever, guys, whenever you use a quadratic, whenever you use a quadratic formula, just know that it's a complex roots. They call it a complex roots. In your book, you will see the section that says complex roots. Complex roots, it means you cannot find the factors, meaning you have a negative square root. That's what it means. So you're gonna say d equals to minus b plus or minus square root of b squared minus 4ac divided by 2a. And then d will be equals to your b there. You're gonna have minus into minus 2 plus or minus the square root of b squared. You'll have minus 2 all squared minus 4a. Your a is 1, and then your c is a plus 5 divided by 2a, which is 2 times 1. And then this will be equals to, what I normally do, guys, please take this advice. You see, the division is for everything. What I normally do, I split this because of the plus or minus sign. I cut it into half. It's your LCM. That 2 is your LCM. So I'm going to write minus, it's a plus 2. The top one, minus and minus, it will be a plus 2 divided by a 2. Then I put a plus or minus in between, and then I say square root. So I'm going to have 4 minus 4 times 5, which is 20. You see, that's why it's a negative. That's why you can't find factors, because it's a negative square root. And then you're going to divide it by 2. So 2 is the lowest common multiple there. I split it into 2 so that I can have d equals to 1 plus or minus a square root of minus 16 divided by 2. The reason why you cannot find factors is because you have got a negative square root. And we know that you are imaginary. The moment you have a negative square root, you're going to say a negative square root of 1 is equals to I, which is imaginary. So this simply means that we have a negative square root of 16, which is equals to minus 1 times a square root of 16. So we make it a positive so that it can be possible. We make it a positive square root by introducing a square root of minus 1. And we know that a square root of minus 1 is equals to imaginary. So this means that a negative square root of minus 16, a square root of minus 16 rather, is equals to I. 16 square root of 16 is a 4. So it's 4I basically. So you'll have d is equals to 1 plus or minus square root of, instead of square root rather, we're going to write 4. We're going to write 4i divided by 2. The 2 is coming from here. So basically I just substituted this back to the equation. So the final answer that you're going to have there, you'll have d is equals to 1 plus or minus 2i. And this is your d. Any question? Did you all find this question? Did you all find this answer? Sorry. Did you all find this answer? Okay. So, guys, since this is your d, whenever your d is a complex root, this is the rule that you use. Let me show you. You use sine and cosine rule because it's a complex root. The complex root, your formula that you use is this guy. Let me show you on the study guide. So you'll highlight on the study guide. Since it's a complex root, it's written there. May I please admit there's someone trying to join? So this guy, since it's a complex root, you're going to use this formula right here. I'll show you where to find it. You see it says hyperbolic, quadratic. So you need to go back to this chapter if you don't understand this. So there's a section where it says complex root. There's a section where it says complex root. It's on this chapter, the first one. Here, it says root complex. Whenever you use quadratic equation, you see they used quadratic equation. Whenever you use quadratic equation, just know that it's a complex root. And then with a complex root, you have to use this formula. You see this formula? For your YCF, you need to use this formula. Always, whenever you use your factors are complex roots or root complex, you always need to use this formula. You always need to use this formula for your YCF. So that's the formula that you're going to use. You always need to use that. So since the factors are complex, I'm going to write here, factors are complex, meaning it's your I, obviously. It's your complex. The formula that you need to use for your YCF, always, it's e to the power ax, open bracket, c1, and then cos bx, and then plus c2 sine bx. Look at this, guys. you know from your basic maths that if it's a complex, you're gonna say m or d is equals to a plus or minus bi. That's what it always says. That's a standard from basic maths. For your complex root, a plus or minus bi. So meaning a will be equals to 1, b is equals to 2. So we're going to substitute that to our formula. This equation, guys, you need to remember it. You must master this equation. So we're going to have a to the power 1, and then x times x, open bracket, c1 cos bx. Our bx is 2, so we're going to write 2 where there's b, and then plus c2 sine 2x. This will be your final answer for your complementary function for your step 1. So far, so good. Or is there any question, any confusion, where you need clarity? Let me know. So far, so good. Okay. Let me admit. Actually, I need to put this thing on auto admit. So for number 2, step number 2. Step number 2, guys, you're gonna find YPI. YPI. So for step number 2, you're gonna find YPI. You go back to the original equation. If you check the original equation, guys, you have to, please don't confuse this thing. They said the operator method, D method. The moment they say D method, you must know that you used theorems to find YPI. Always you use theorems. Right. I'm gonna do this. So you go back to original equation to find YPI. You see the Y that is outside there, you're gonna write YPI. When you write YPI there, meaning you have to make that YPI the subject of the formula by dividing. I'm gonna highlight it with a different color. You have to divide both sides by that guy there. So that's what you're gonna do. We're gonna go to our second step, number 2. So YPI will be equals to, you have x plus 5 divided by d squared minus 2d, and then plus 5. Okay, that's what you're gonna have. I can tell you now for free, guys. If you look at this guy, your YPI, it's not a quadratic, because if you look at the denominator, I always told you the denominator, okay, it doesn't matter. Denominator just tells you that you need to use the operator method, and then the numerator is the one that decides to say you need to use the theorem. It tells you which theorem you must use. You must choose the theorem that you're gonna use. So guys, always whenever you see something like this, just know that if there's a plus in between and there's no relationship, these guys, they don't use the same theorem. It's a constant versus a variable. It's a constant versus a variable. They don't use the same theorem. Let me show you. So we're gonna go to your study guide. I'm gonna show you. They don't use the same theorem. So we go back to our theorem on page 57. I'm gonna show you that they use different theorem. We are done with theorem. I showed you how to do the theorem for a constant, which is theorem 1.1. So I'm gonna show you now the theorem that you need to use there. Theorem 1.1, I did explain it. We've used this one. Then I'm gonna show you the next theorem, which is this one, 1.2. You will see when to use it. And then there's a theorem for your trigonometric functions. And then there's a theorem also for your constant. There's multiple theorems there. So since now you've got a constant, you see there, for your constant, please refer to this example. Constant, I mean 5, this one, because they don't use the same theorem. So what's going to happen there is that you're going to split these two. Remember I told you that they use different theorem. So you're going to split the two. So your YPI, you're going to split the two. That's why I highlighted there. You're going to have x divided by d squared minus 2d plus 5. And then you're also going to have plus 5 divided by, they use different method or different theorems, plus 5. So you're going to split the two because they don't use the same theorem. For your constant, I already explained this part. There was a lady that was asking me, why did I use, sorry, I didn't get your name. So someone asked me, why did I use e to the power 0x? It was because of the theorem. You see, they say when q is a constant, to find your YPI, I just summarized this whole thing. To find your YPI, you need to say e to the power 0x, which represent e to the power 0, which represent 1, meaning it doesn't have any impact to your equation. And that's exactly what I did. Remember, I did use this thing. I did say a constant times e to the power 0x. That's exactly what I did. You see? Nice. The first example that I did, that's exactly what I've used. So for that constant, guys, you can use example 1 and example 2 for your constant. That's your reference. You can reference it from page 65 and 64 for your reference. For this question, just gonna write there. In your study guide, it's 64, page 64 and 65 for your reference, in case you want to do more examples. So I already went through something like this. So I'm gonna take it down. We're gonna go to the second one after. This one, I'm gonna treat it as a separate equation. I'm gonna get rid of that 5 over d squared minus 2d plus 5. So I'm gonna take it down, put it here, solve it. Guys, if you have any question, please let me know. Don't just let me move and then without you understanding. Please, you can pause and I explain. So I already told you that since the numerator is a constant, you just need to introduce e to the power 0x. 0x represents 1, so it doesn't affect your constant. That's why. And then we know that the theorem for e to the power 0ax, it represents e to the power ax, which says a is equal to d, which is equal to 0. So where there's d, we're going to put 0. So we will have 5 over 0 squared minus 2 into 0 plus 5, which is equal to 5 over 5, which is equal to 1. That's how you're going to solve that guy. Is it clear? Is it clear, guys? Okay, perfect. Perfect. Then we reference. So I also showed you, I'm using your study guide as a reference so that you see where I take these methods. And then you don't have to worry. You don't have to worry. So I'll explain on the next session. So I'm gonna try to organize a session for Wednesday, guys. We're gonna have, I want us to have as much sessions as possible so that we can cover this whole assignment. So after this session, I'm gonna send another link for Wednesday so that we can have another session on Wednesday. So I'll take you through these examples as we move along, because I'll explain why they got that 5x over 2. There's a reason why they got that. Then now we go to the next one. You see, as we're moving, this one says you have got q as a polynomial. So q basically it's x. So you've got q as your x. That's exactly what we have there. That's your example 3 there. Just that in this case it's not raised to the any exponents or any degree. So it's this one. This section is similar to what we have. So you see how they found your YPI. They used this method. Then normally call it binomial theorem. So you can use multiple methods here to solve this guy. So they decided to use a binomial theorem. Sometimes you can use a long division. It's up to you which method you are comfortable with. You can use any method to solve this question. I know someone can ask, why did they use a binomial theorem and not a long division? It's up to you. You can use any method. So I'm going to show you both methods. So you're going to start with long division. You can also use long division. For me, I find long division simple. You know why? Because long division, most of you guys are familiar with it. The binomial theorem, for binomial theorem, you need the formula. You need that formula. This formula there. You need to understand this formula. So to understand the binomial theorem, you need to understand this formula there. Sorry guys, I lost connection. Sorry about that, guys. I lost connection. My network just switched off. Sorry about that. I think we shall proceed. It's fine. Sorry about that. Is it still presenting? Okay, perfect. So I was saying the binomial theorem, guys. I don't like it, but you can use it if you want to. You can use it if you are comfortable with the binomial theorem. You can use it. You just need to understand the formula of the binomial theorem. You just need to understand the formula, then you'll be sharp. You'll be sharp. Once you understand the formula, then you'll be sorted. But I prefer the long division method because most of you guys are familiar with long division method. So there's multiple methods that you can use. So you're gonna take the x as your numerator. So with long division, do you still remember how long division works? So your numerator, between your numerator and denominator, which one comes? You have something like this. I don't know if I can call it. It's not L. I don't know what shape is this, but you still remember the configuration of this thing. Which one is your numerator? Which one is your denominator? Like normally, how do you put it? And also, just know that when you use long division method, you use it in reverse. So basically, what I'm saying in reverse is that the last one will be the first one, so it will be in reverse, meaning it's gonna be in this form: 5 minus 2d plus d squared. It will be in reverse. You're gonna formulate it like that. I think in your book there's something like that. There's a section where they've used long division method and then they put it in reverse. So I'll try to get that for you guys. Oh, there we go. You see, there we go. Just talking about it, there it is. So if you want to use the long division, you see there, you can use it. It's example 4. Example 4 uses a long division because here you've got polynomial. You see it's still under the same section. It's still under 2.1.2 where q is a polynomial of x. It doesn't matter what is it. So it's still under the same section. So they've decided to use a long division method. So I prefer the long division because it's always easier to use. That's my take. But then if you want to use the other method, you can use it. It's up to you. It's up to you. So a long division method, guys, will never go wrong. That's my take. It's fine. Okay, so you see the reverse that I'm talking about is this one. If you look at the original was d squared plus 3d plus 2. And then when you do the long division, you reverse it. Okay, that's what you're gonna do. So the reason why they write 1 here, it's because we don't have d. It's more like they just put times e to the power 0x. Because we don't know, we do not recognize this x. We want to use d. Everything is d, or is d to the power 0. Okay, to make it, for argument's sake, we can say they just use d to the power 0. Because we don't know, we want to use, everything must be in the form of d. Remember when you use long division, guys, it must be in the same form. You can say they decided to say d to the power 0 so that everything can be in the form of d. You can say they decided to put d to the power 0 so that everything can be in the form of d. Then I already explained the reversing. We write it this side plus d squared. So to reference this one, I just showed you the page. It's on page, let me check. I'll tell you just now. It's on page 68. It's on page 68 to reference this one. Then we're gonna use the b. So we're gonna say DMSB. So this DMSB, it means divide, multiply, subtract, bring down. That's the method that I normally use. So we're gonna take the one we divided by 5, the first one. So we're gonna say this guy divided by this one. So we'll have 1 over 5. Then from there, we are done with division. We go to multiply. And then we're going to say 1 over 5 multiplied by everything. So it's more like 1 over 5 multiplied by 5 minus 2d plus 2 plus d squared. And then we're going to have 1 over 5, which is 1. So we'll have 1. It will take us to the original. We'll have 1, and then the next one will have minus 2d over 5. This one is quick, guys. If you look at this, the long division is very quick because you're going to have the remainders there. So on top there, that's your remainder. You must have at least 3 remainders, guys, not less than that. On top, not remainders, actually, your equation. You must have 3. There must be 3 there. You must not have less than that. So you'll have 1 minus 2d over 5, then plus d squared divided by 5. Then you are done with multiplication, and then you go to subtract. This is the third one, subtract. So when we subtract, we're going to subtract everything with that one. So we put a bracket there, we put a minus. That's when we subtract. So we're going to say 1 minus 1, and then you get a 0. And then everything multiplied by minus, you'll get a plus 2d divided by 5 minus d squared over 5. And then you are done with subtraction. And then they say bring down. There's nothing to bring down there. It's a plus 0, so you're gonna bring down 0, nothing. And then you go again, you start the process. Since you are done with division, multiplication, subtraction, and bring down, you start over. And then now our next value is 2d divided by 5. So you're gonna do the same thing. 2d divided by 5 divided by 5. You're gonna get 2d because these two are gonna cancel. You're gonna get plus 2d. And then you multiply. You are done with division, then you multiply. When you multiply, you're gonna say 2d over 5. You multiply by 2d multiplied by everything that is there. Sorry, not that. You multiply by everything that is there. You multiply by everything that is there. It must take you back to the original. Are you guys familiar with this long division? You are familiar with long division? Don't worry, I've uploaded a video. So guys, I've uploaded the videos on the website. I'll share the link for the website. So I've uploaded a lot of videos on the website online. So you can always access those videos. They are free. I shared everything is there for free. So let me just show you, because we have 1 minute left actually, unfortunately. But then we're going to proceed on Wednesday. Don't worry. I'll share the link now. So I just wanted to show you the website where you can get all these videos, because for those who want to watch more videos. So you just go to convenientechacademy.com. So just go to Math 3, this one. You just go to 3rd year mathematics. You say start learning. You'll see there's a lot of videos there. I've uploaded a lot of videos. You see, you can go to homogeneous equation, you go to second order differential equation, you go to method of undetermined, you go to the operator method, Under the operator method, there's a general solution by using the operator method, simultaneous equation. You can go through everything. Method of undetermined, you see there. I did right there where Q is a constant, Q is X. This is the one that you're looking for. Q is X. You're gonna see all the sessions there. When you go through this, you're gonna see a lot of sessions there. Real roots, there's everything, guys, that you need there. So I'm planning on uploading more videos. You'll see there's a lot of videos. By your side, you'll see them because I'm accessing it as an admin. But you'll see direct integration, separable method, you'll see everything is there with exercises. Obviously there's examples. I've also attached your, in case if you don't want to watch the whole video, there's a memorandum also. So yes, I'll share the link on the group, don't worry. You see, you can even download this. If you want to download this, you can even download it. I did it as a picture. You can download it and do your, that's your memo actually, and the examples. And then if you want to watch videos, you can click on that video there. There's your video. Don't worry, on Wednesday I'm gonna share the link for Wednesday, guys, and then we will proceed on Wednesday. I'll take you through everything on Wednesday. If you have any question in the meantime, we can discuss it on the group, ne? Because we have only 1 minute left, and then the session is gonna end. I'm looking at the clock. You see that it says 2 minutes. You can see there. So yeah, let me share everything on the group, and then this session was recorded, so I'm gonna also share it on the group, ne? For those who want to do recap, Wednesday we are going to continue with the session. So I'll send you the guys the link for Wednesday, ne? Otherwise, have a lovely night, guys. I'll see you on Wednesday. You're welcome, guys. Bye. Bye.